tell whether the table represents a linear, exponential, or quadratic function. That's your first part of the examples. Then write the function. This is the part that is the harder part, is writing the function. Identifying what type of function it is the easier part. The harder part is actually truly writing the function. So, for these three examples, we're going to first identify whether it's an exponential, a linear, or a quadratic. And then we're going to actually write it in either this form, or this form. Okay? Now, the thing is, I haven't given you any y values yet. So, now obviously because I have this table under linear, it's going to be a linear function. I have this table under exponential, it's an exponential function. I have this one under quadratic, it's going to be a quadratic, so I don't confuse you. Okay? Alright, so, but we're not going to do them in the order of linear. Well, yeah, I'm going to do linear first. Alright, so here we go. Here's my first example. Alright, there's the... Now, I waited to put the y values up, because that's the key. If I were to look at this table, the first thing I want you guys to look at, what do you notice does not change in all three of these tables? In terms of the tables themselves and the values. Do they all have the same domain? Do they all have the same x values? Yes. So nothing changes in the domain. It's the range that I'm looking at. I'm looking at the y values, the output. Okay? Here's how we figure out that this is a linear function right here looking at this. What I do first of all is I ask myself, is there a constant increase or constant decrease with my y values? Am I adding or subtracting the same number to all my y values? Let's see if it happens. Ask myself, what do I need to do to -2 to get 1?
Add 3.
I'm going to add 3, aren't I? Okay, tell me, if I add 3 here, am I adding 3 again to get 1 to 4?
Oh, yeah.
I am, aren't I? Okay? Am I adding 3 to 4 to get 7? Yes. Am I adding 3 to 7 to get 10? So because I have a constant increase or a constant decrease, it is a linear function. That is the key. Am I adding the same number to every one of the y values, or am I subtracting the same number? If I am, I automatically know it's a linear function. Does that make sense? Okay. Now that I know it's a linear function, let's all write linear function. We know this is a linear, because that was the first thing I asked you to do on the example. Tell whether the table represents a linear, exponential, or quadratic function. This is a linear function. Now, the next part is the part we have to make sure we write it in this form. Now, I already have one of the two pieces of information. I just figured it out. Did I figure out the slope or the y-intercept by saying that I add 3 to every y value? What do you think that is? That's the slope, right? What I'm constantly increasing by or decreasing by is my slope. So this right here is my slope, my m. So my m is 3. What else do I need to figure out in order to write it in slope-intercept form besides my slope? My y-intercept. Can you look up on the table right there and tell me if you can find the y-intercept?
4.
It's 4, isn't it? Yes. Because whenever x is 0, what is y going to be? In this case. When x is 0, whatever your y value is your y-intercept. In this case, what is it? It's 4. So I've identified my y-intercept. My y-intercept is 4. Whenever my x is 0, whatever my y value is my y-intercept. Do I have enough to write it in slope-intercept form now?
Yep.
All right, what is it? Y equals, which is 3x plus 4. You got it. And there is my linear function. So the harder part, again, is not necessarily the part of identifying what type of function it is. It's the harder part is identifying, writing the actual function itself. Okay? And how do I know it's a linear function? What was the key? And what did I do to each one of the y values? I added 3 to every one of the values. So once I knew I was adding by a constant number, or if I'm decreasing by a constant number, or adding or subtracting, I know it's automatically going to be a linear function. Okay. All right. Does that make sense? Can I move on to exponential?
Yeah.
All right, exponential. Let's go ahead and see what this one is. I'll pick one on my book here.